What's up, astronomers? Welcome back to another video on the Simplified Astrophysics channel. Today, I'm going to give you everything you need to sound smart and understand our enigmatic universe. We'll be talking about the expansion of the universe and Hubble's law, and we'll examine how these theories came to be. By the end of this video, I'm confident you'll have about everything you need to be a scholar on the universe. Let's get started. In the field of astrophysics, every time you think you've mapped out the universe properly and estimated the size of all known objects, it turns out everything is often much bigger than you think it is. That Earth is a few thousand miles this way, that nearby star is actually a few 100 million light years over there. And it turns out that you were wrong, that our enigmatic universe has eluded you. So a long time ago, there was a dude named Aristotle, and he thought he got the universe solved. It was simple. Earth was at the center and orbited in circles by 7 planets, including the sun and the moon. It was perfect until a dude named Copernicus came and said Aristotle was wrong. Copernicus said that the Earth, along with 5 other planets, orbited the sun. To top things off, he even said the moon orbited the Earth. But he maintained that these were all circular orbits around the sun, so a guy named Kepler came and said he was wrong. And Kepler was like, dude, they're obviously elliptical orbits and they follow these 3 laws. And then he was like, alright, peace out, folks. So that leaves us at about the 1600s. If we fast forward to about 1890 to 1900, we'll have all the planets in our solar system and a few more perks. But those previous things pretty much sum it up. Actually, I skipped over a lot, but it'll be fine. Now in the 1920s, these real strange things called spiral nebulae started popping up in people's telescopes, and it was really weird. Now it wasn't the fact that these nebulae themselves that were showing up, it wasn't that fact that made it weird, but it was what they were doing that made it kind of strange. Astronomer Vesto Slipher was able to examine these objects, and he discovered they had a Doppler shift. He measured that shift and found that these objects were receding from Earth. They were moving away from Earth. Now that may not seem too incredible or anything, but let's back up and consider what was commonplace at that time. In the early 20th century, it was often held that our galaxy was standing alone in our universe, that the universe was just our galaxy. Those nebulae that were showing up in people's telescopes weren't too far from us, and they couldn't be because our universe just wasn't that big. Okay, but if those spiral nebulae thingamabobs are receding from us, then maybe we need to take a step back and reevaluate the structure of the universe. And what is the best way to reevaluate the structure of the universe? Fight, 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 fight. No, not a fight, you moron. A civilized fancy debate between 2 PhD astronomers using high-level diction held at the Smithsonian Museum right after the First World War. People these days, I can't even believe this guy. Can you even believe this guy? What's he doing? So there literally was a live debate on this topic, held in a format somewhat like the presidential debates. Actually, maybe not. I'm not sure if there was a moderator and if things were actually that heated. But 2 astronomers, Harlow Shapley and Herbert Curtis, publicly debated this in a live format on April 26, 1920 at the Smithsonian. Shapley was convinced the spiral nebulae were just nearby small nebulae within our own galaxy. Curtis, on the other hand, thought that the spiral nebulae were not nebulae, but galaxies of their own, like our Milky Way, and were really far away from us. Okay, so that debate on the universe was very cool. It turns out that both Curtis and Shapley were right and wrong on multiple things, but one was more right than the other. We'll get to who that was in a minute. What? You fool! I want to know now! Alright, that's fine. No need to be so feisty about it. Okay, just click on, go to this time right here, or somewhere. Maybe it's there. If you're still here though, let's take a step back and examine the 2 competing theories on the spiral nebulae. So right here on the green team, we have American Dutch astronomer Adrian van Manen and his gang. They were with the idea that the universe was not bigger, that those spiral nebulae thingamabobs were local, and that the spiral nebulae weren't receding, but rotating. They had calculations to back it up, and it was perfect until some other folks came along and told them that they were wrong. And over here we have the orange team, and we're going to say it's led by astronomer and former lawyer Edwin Hubble. Now their thing with these spiral nebulae stuffs was that they were real far away. So far away that the spiral nebulae were not spiral nebulae, but instead spiral galaxies. These calculations and conclusions led to additional research, or I guess it was independent research, and Belgian priest and astronomer Georges Lemaître corroborated these theories with the conclusion that the universe was expanding. So we've set ourselves up for a great fight here, but if you've studied some astronomy, you know the story, and you know who wins. It's the orange team! Edwin Hubble's conclusions were accepted by the scientific community. By calculating distances to Cepheid variables within the spiral nebulae from Mount Wilson Observatory, he formed the basis of our current knowledge of the universe. So what this means is that the universe is expanding. Hubble determined a law that the velocity of an object's recession from us is directly proportional to its distance from us, better known as Hubble's law. This law is used to calculate recessional velocity of objects in the universe. That symbol h sub 0 is a constant we call Hubble's constant. You can tell it took them a real long time to come up with these creative names. One important thing about these discoveries is that for the first time, we truly understood just how big our universe is. We went from thinking it didn't extend much beyond our planet, to not much beyond our solar system, to not much beyond our galaxy, to really big. For the first time, we truly grasped the magnitude of our universe, and I guess just how small and maybe even insignificant we are here on Earth. You may still be wondering about that 1920 debate on the universe. Who won? Curtis correctly concluded that these spiral nebulae were in fact not nebulae, but distant galaxies, something Shapley messed up. But he incorrectly put the sun at the center of the galaxy, something Shapley didn't mess up. Since the spiral nebulae were the main issue, we'll say he's the somewhat winner. Well, that is all really cool, but I want to follow up on everything I just talked about. Mainly because these theories were not determined by just these people in such a short amount of time. There were so many people that probably came up with these kind of theories and assertions that the universe is expanding, that these spiral nebulae are galaxies and whatnot. It wasn't just Hubble and Lemaître. For example, the theory that there are other galaxies can be seen in Immanuel Kant's island universe theory of the 1750s. Using some studies and his intuition, he wrote that there were galaxies other than our own, and he called them island universes. I probably can't even count how many people had the right intuition in a world stuck on the wrong one. Ideas about our universe have been going around for so long. New research and developments may expand upon these ideas, or they may debunk them totally. Now, our ideas about our amazing universe haven't always been right, but they have led us as close as possible to what is right. So that's all on our universe today, but there's so much more. If you want to see more on our universe, well, drop a like and hit that subscribe button, and leave a comment while you're at it too.